faster than the fabric of space-time can keep up with it, and it'll just rip, and I'm terrified by this. A cosmic spectacle is unfolding as we speak, captivating astronomers worldwide. Betelgeuse, that mesmerizing red supergiant adorning Orion's shoulder, is undergoing a remarkable metamorphosis. Its luminosity, the radiant glow that defines its celestial presence, has undergone an extraordinary surge, surpassing its customary brilliance by an astounding 50%. At the dawn of this year, Betelgeuse proudly held the illustrious title of the 10th brightest star gracing our nocturnal canvas. However, this unexpected celestial blow-up has propelled it to a prestigious new position, now shining brightly as the 7th star in our inspiring night sky. Betelgeuse, a massive star in its late stages of life, is of immense size. Its dimensions are so vast that if it were positioned at the center of our solar system, it would extend as far as Jupiter's orbit. Eventually, this star will undergo a collapse, resulting in a powerful supernova explosion which may lead to the formation of either a neutron star or a black hole. The anticipation surrounding Betelgeuse's supernova stems from the fact that it will be an extraordinary event. Positioned roughly 650 light-years away, humanity finds itself in an optimal location to witness this cosmic spectacle firsthand. When the stellar explosion occurs, it will produce a breathtaking display of light. Initially, there will be an abrupt influx of neutrinos that will sweep across the Earth, detectable by observatories worldwide. Following this, as high-energy photons escape from the expanding cloud of stellar debris, Betelgeuse will rapidly intensify in brightness over the course of a week, reaching up to 100,000 times its usual luminosity. Depending on the explosion's power, this celestial beacon could rival the brilliance of a full moon and might even be visible during daylight hours, casting distinct shadows at night. This magnificent event will persist for an extended period, offering an unparalleled opportunity for detailed observations and potentially groundbreaking discoveries. While the supernova of Betelgeuse may trigger speculation and apprehension due to historical associations of such events with ill omens, we can take solace in the fact that we are safely situated at a considerable distance, shielded from any detrimental effects. To fully comprehend the enigma surrounding Betelgeuse, it is crucial to revisit the end of 2019 when peculiar phenomena began to manifest. During this period, the red supergiant star started experiencing significant dimming, a change noticeable even to the naked eye. Observations using the Very Large Telescope in the optical spectrum revealed that Betelgeuse appeared roughly symmetrical, but its photospheric layers exhibited signs of substantial disturbance within our line of sight. The photosphere represents the outer layer of the star where light is emitted. Researchers also detected an expansion of the photosphere, giving the impression that the star was swelling when viewed from Earth. This expansion continued at a constant rate of approximately 8 kilometers per second for most of the year until mid-November 2019, at which point the outward velocity began to decline. By mid-November 2019, the flow of material from Betelgeuse ceased, prompting astronomers to capture new optical images of the star. Their observations revealed two surprising irregularities. Firstly, a darkened region appeared in the star's southern hemisphere, creating a striking contrast with the previous image taken at the beginning of the year. Secondly, the surface temperature of the star experienced a dip, dropping by approximately 80 Kelvin. Between January 27th and February 13th, 2020, the brightness of Betelgeuse reached an unprecedented low. Approximately a year after the cessation of the outflow, the star gradually regained its brightness over the following months, eventually returning to its normal magnitude. This led to the question, what had truly happened with Betelgeuse? All the available evidence strongly suggested that Betelgeuse had undergone an immense and unprecedented event known as a surface mass ejection, SME. This phenomenon bears similarities to coronal mass ejections, CMEs, observed on the Sun. To better comprehend SME, imagine a volcanic eruption on a scale matching that of a star. Material from the star's interior surges upwards and outwards, causing shock waves within its atmosphere. Over time, this material forms molecules and dust, partially obstructing our view of the star and causing it to appear dimmer. In the case of Betelgeuse, the SME resulted in the ejection of a mass 400 billion times greater than what is typically observed during similar events on other stars or CMEs. This amount equaled multiple times the mass of the Moon, propelled at astonishing speeds. Researchers noted that such an enormous mass ejection from a star's surface had never been witnessed before. The event allowed for the direct observation and examination of surface details using the Hubble telescope, offering a real-time glimpse into the aging and evolution of a dying star. The SME had a profound impact on Betelgeuse, causing it to lose a significant amount of mass in a single event. This occurrence demonstrated that a dying star can experience substantial mass loss beyond its regular annual decrease due to stellar wind. In a way, it was as if Betelgeuse had forcefully expelled its upper layer and was presently in the process of slowly recovering from the aftermath of this injury. However, following this dimming event, the star's behavior has undergone a change. Previously, it would pulsate or alter its brightness every 400 days, but now it is pulsating every 200 days. Betelgeuse is classified as a semi-regular variable star, meaning it experiences multiple cycles of fluctuating brightness due to variations in its size and temperature. This red supergiant is known to exhibit two main periods of light pulsation. The first period lasts 400 days and is believed to be caused by pulsations in the fundamental mode. The second period is a longer cycle of approximately 5.6 years, and its origin remains unknown. In their research paper, scientists utilized computer simulations to gain a deeper understanding of the events that transpired. They proposed that an unusually hot gas current resembling a large and intense bubble emerged from within the star. These occurrences of hot gas bubbles occasionally arise due to the star's turbulent and convective envelope, which can be likened to a pot of boiling soup where the material is constantly in motion and mixing. As this hot bubble ascended and broke through the star's surface, it triggered the ejection of stellar material. Interestingly, it also disrupted the star's regular pulsation pattern. The star's surface continued to expand while its deeper regions contracted, causing the star to transition from its customary 400-day pulsation to a new 200-day pulsation. Astronomers anticipate that the star's regular motions will gradually stabilize, and the unusual pulsation over the next 5 to 10 years will ultimately restore Betelgeuse to its normal 400-day pulsation. Regarding the possibility of a Betelgeuse supernova, astronomers speculate that it could occur at any time within the next 10,000 to 100,000 years. Based on factors such as the star's color, brightness, size, and estimated age, scientists suggest that Betelgeuse is currently in the early stages of helium to carbon fusion. This process must continue through oxygen, silicon, and finally iron before the star's core collapses under its own gravitational pull, leading to a cataclysmic explosion. Since Betelgeuse is located 650 light-years away, any supernova event happening at present would only become visible to us after 650 years due to the limitations imposed by the speed of light. Therefore, it is highly unlikely that we will witness the star's dramatic demise during our lifetime. The unique thing about Betelgeuse is that we can actually see its surface, which isn't the case for most other stars. This gives us an incredible opportunity to learn about how big stars like Betelgeuse behave as they get older, including these kinds of surprising mass ejection events. Recently, astronomers made a bone-chilling discovery. For the first time ever, they observed a star eating its own planet 12,000 light-years away in the constellation Betelgeuse. With its intriguing name and prominent position in the night sky, Betelgeuse has captivated the human imagination for centuries. Its significance extends beyond scientific knowledge, as it has left its mark on pop culture and mythology around the world. Betelgeuse has a rich and diverse origin rooted in the Arabic language. Initially interpreted as the armpit of the giant, some scholars argue that it may represent a hand or shoulder instead. This anatomical association is reflected in various interpretations of Betelgeuse, often linked to anthropomorphic or animal figures across different cultures and mythologies. Betelgeuse carries multifaceted meanings and symbolism. In ancient Japan, it represented a severed limb, while in Brazil, it was perceived as a turtle's leg or a caiman's hind leg. The Sanskrit term for Betelgeuse translates to the moist one, tied to Hindu astrology Ardra lunar house and associated with the tempestuous storm god Rudra. Throughout history, Betelgeuse played a significant role in cultural practices and traditions. For instance, in Macedonian tradition, it symbolized domesticated animals and agricultural life in villages. In other regions, such as North Island and the Melville Peninsula, its rising marked the onset of spring and longer days. Betelgeuse's cultural prominence stems from its affiliation with the constellation Orion, where it is recognized as the star on Orion's right shoulder. As one of the brightest stars in the sky, ranking 11th in luminosity, it captivates and inspires artists, writers, and filmmakers. In recent years, Betelgeuse has undergone unprecedented changes, catching the attention of astronomers worldwide. From significant dimming events to a massive surface mass ejection, SME, Betelgeuse has exhibited behaviors never before observed. The explosion of Betelgeuse would be a spectacular event, attracting both scientific interest and media coverage. However, it should not be cause for alarm or fear, as humanity would not be endangered by it. Observing the death of a star presents a rare opportunity for astronomers to gain insights into the life cycle of stars, the mechanisms behind their explosions, and the formation of new celestial structures. It serves as a reminder of the universe's dynamic and ever-changing nature, encouraging exploration and deeper understanding of the cosmos. The transformation of Betelgeuse signifies the death of a star and its subsequent rebirth in an astonishing burst of light. Betelgeuse, also known as Alpha Orionis, continues to intrigue astronomers with its dynamic behavior and significant impact on our understanding of stellar evolution. Situated prominently in the constellation Orion, Betelgeuse has garnered attention not only for its astronomical importance, but also for its cultural and mythological significance spanning centuries. A red supergiant star, Betelgeuse is nearing the end of its life cycle, characterized by its immense size and unstable nature. Its diameter is estimated to be about 1,000 times that of our Sun, making it one of the largest stars known. Despite its enormous size, Betelgeuse is not a stable entity. It pulsates and varies in brightness over time, reflecting its internal turbulence and impending demise. One of the key aspects that fascinates astronomers is Betelgeuse's potential to undergo a supernova explosion. While the exact timing of such an event remains uncertain, scientists speculate it could happen any time within the next 10,000 to 100,000 years. When Betelgeuse exhausts its nuclear fuel, particularly during its fusion processes from helium to heavier elements like carbon, oxygen, silicon, and eventually iron, its core will collapse under its own gravity. This catastrophic collapse will trigger a powerful explosion, releasing an immense amount of energy and material into space. The aftermath of a supernova explosion from Betelgeuse would be a spectacular sight, visible even from Earth. Despite its distance of approximately 650 light-years, such an event would temporarily outshine the combined luminosity of all the stars in the Milky Way galaxy and could potentially leave behind a neutron star or even a black hole, depending on the star's initial mass. Astronomers and researchers worldwide are keenly observing Betelgeuse, monitoring its fluctuations in brightness and spectral changes for clues about its impending fate. Recent observations have revealed intriguing insights into its variability, including changes in its pulsation patterns and surface dynamics. In addition to its scientific significance, Betelgeuse holds a prominent place in human culture and mythology. Its name originates from the Arabic phrase Yad al-Jaza, meaning the hand of Jaza, which refers to one of the star's earlier interpretations as part of Orion's figure. Across various cultures, Betelgeuse has been associated with different symbols and meanings, reflecting its prominent position in the night sky and its impact on ancient societies' beliefs and practices. In ancient Egypt, Betelgeuse was linked to the goddess Isis, symbolizing rebirth and renewal. In Norse mythology, it was associated with the giant Hörner's heart, signifying strength and resilience. Such diverse interpretations highlight Betelgeuse's universal appeal and its role in shaping human narratives about the cosmos. Technological advancements have enabled astronomers to study Betelgeuse in unprecedented detail. Instruments such as the Hubble Space Telescope and ground-based observatories, equipped with advanced spectroscopic and imaging capabilities, have provided valuable data on Betelgeuse's surface dynamics, chemical composition, and evolutionary stages. Recent studies have also focused on Betelgeuse's mass loss mechanisms and the impact of its stellar winds on surrounding interstellar material. These findings contribute to our understanding of how stars evolve and interact with their environments, shedding light on the broader processes that shape galaxies and cosmic evolution. Moreover, Betelgeuse's variability offers insights into the fundamental physics of stellar pulsations and instabilities. By studying how stars like Betelgeuse pulsate and change in brightness over time, scientists can refine models of stellar structure and evolution, improving our ability to predict the behaviors of other stars across the universe. Beyond its scientific and cultural significance, Betelgeuse continues to captivate the public imagination through popular media and entertainment. Its portrayal in literature, films, and art reflects its status as a celestial icon and symbol of cosmic wonder. From science fiction novels exploring the implications of supernovae to blockbuster movies depicting distant worlds and interstellar journeys, Betelgeuse's influence extends far beyond the realm of astronomy. Looking ahead, astronomers will continue to monitor Betelgeuse's evolution and variability, anticipating future observations that could provide further insights into its ultimate fate. Whether Betelgeuse will indeed undergo a supernova explosion in our lifetime remains uncertain, but its ongoing transformation offers a compelling opportunity to deepen our understanding of the universe and our place within it. In conclusion, Betelgeuse stands as a testament to the awe-inspiring complexities of the cosmos. From its immense size and variability to its cultural significance and potential for a dramatic supernova explosion, Betelgeuse continues to challenge and inspire astronomers and enthusiasts alike. As humanity continues to explore and unravel the mysteries of the universe, stars like Betelgeuse serve as beacons of discovery, reminding us of the dynamic and ever-changing nature of our cosmic environment.